Hello, geometry people. Today's lesson is on rectangles. Now, a rectangle is a parallelogram, recall? But what makes a rectangle different is that its diagonals are congruent. Diagonals are congruent. So one thing that happens is that a lot of the rectangle problems involve the diagonals. So here is rectangle A, B, C, D, and the diagonals intersect at E. Now, we can have a problem like this. AC is equal to 3x plus 7, and BD is equal to 5x minus 3. Well, AC is a diagonal, BD is a diagonal. We know that AC is equal to BD. So therefore, we would simply say 3x plus 7 is equal to 5x minus 3. And let's solve this now to find x. By minusing 3x from each side, 7 equals 2x minus 3. Let's add the 3. You get 10 is 2x, and we'll finish this problem by dividing by 2, and you get 5 is equal to x. So if we look here, AC is equal to 3 times 5 plus 7. 15 plus 7 is 22. BD is equal to 5 times 5 minus 3. 25 minus 3 is 22. Our problem checks out. Now, since a rectangle is a parallelogram, the diagonals also bisect each other. So let's do another problem. Let's say AE is equal to 15 and BD is equal to 7x plus 2. Now AE right here is 15. And since the diagonals bisect each other, that means EC is also 15. So if AE is 15, AC, the entire diagonal, is 30. And BD is the other diagonal, so our problem here would be 30 is equal to 7x plus 2, since the two diagonals are congruent. 28 is equal to 7x. 4 is equal to x. Okay? Now, the other thing about a rectangle that people sometimes tend to forget is that it has 4 right angles. So let's take a look at this problem. It's going to be A, B, C, D. They intersect at E. Let me label some of these angles. This is angle 1. Oh, let me get that pen working. This is angle 1. This is angle 2. This is angle 3. And this is angle 4. Now, since angle DAB is 90 degrees, 1 plus 2 together is equal to 90. So they're complementary. Same thing up here. Angles 3 and 4 together add up to 90. They're complementary. But since it's a parallelogram and the top and bottom are parallel, we can think of this as a transversal, and it forms the letter Z. Let me draw in that Z for you. That means angles 3 and 1 are equal. So there's a lot of situations that could occur with this problem. What we could say angle 2 is equal to 6x plus 15, and angle 3 is equal to 2x minus 5. Well, here's angle 2, here's angle 3. A lot of ways to approach this, but since angle 3 is equal to angle 1, and angle 1 and 2 are complementary, that means 2 and 3 are also complementary, which means it adds up to 180 degrees. 90 degrees. Complementary adds up to 90 degrees. Let me get that right. 6x and 2x combining like terms is 8x. 15 minus 5 is 10. Minus the 10. 8x is 80. X is equal to 8. Sorry, x is equal to 10 when you divide by 8. Alright, now let's take a look at another one. Let's say the measure of angle 2 is equal to 62 degrees. Alright, right there, 62. Let's find the measure of angle EDA. Okay, this right here is 62. EDA is this angle right here. Well, there's a lot of ways you can do this, but take a look at this triangle right here, triangle DEA. What kind of triangle is it? Well, it's an isosceles triangle, because these two right there are congruent. Those are the legs. These are the base angles. If angle 2 is 62, EDA up here, the other base angle, is also 62. So we end up having problems that involve isosceles triangles. Let's do one more, then we'll finish this lesson up. How about this problem right here? The measure of angle DEA is 50. Find the measure of angle 2. Well, where's DEA? Right here. That right there, DEA, is the vertex angle of the isosceles triangle. Remember how we did those problems? If 50 is the vertex angle, you do 180 minus 50 and you get 130. The two base angles together add up to 130, so divide 130 by 2 and you get 65 as our answer. So there's going to be lots of different types of problems involving rectangles. The two primary ones are the diagonals are congruent, and then we use the fact that we have 90-degree angles. And we can do lots of different type of geometry problems involving the 90-degree angles. Okay, let me stop the video.